Hi there, and welcome to Telefunken. Today's video is the first in a series on the vintage Dynacord Echocord Super Model S62, an analog tube-based tape echo made in 1964. Dynacord may not be a well-known name here in North America, so it may surprise some of you to learn that Dynacord is actually a very well-established brand, having been around for more than 70 years. Dynacord was founded in 1945 when the newly released prisoner of war and engineer Werner Pinternagel established a workshop in the small Bavarian town of Pilsting in West Germany. Initially, the workshop specialized in radio repair. However, with time, they began to build professional audio equipment. In 1947, Pinternagel moved the company to Landau and began to focus on the production of amplifiers for movie theaters. In 1948 and 1949, their first mixers and amplifiers came onto the market under the name Dynacord. The company had considerable success, selling more than 70,000 of the DA15 mixer amplifier model, which was produced for 10 years. In the 1950s, the development of the Echocord began, and in 1958, the company moved its headquarters to Straubing, and the first Echocord model was released in 1959. Throughout the 1950s, American guitarists such as Les Paul and Chet Atkins had been using slapback echo in their productions, and Ray Butts had released the Echosonic amplifier, a favorite with the rockabilly scene. But it was in the 60s when the echo effect really took off, with the 1960 release of the Shadows hit Apache and the Ventures' Walk Don't Run that same year. Soon enough, echo was everywhere, and the echo and reverb-laden sound of surf guitar was in high demand. This ensured the longevity of the Echocord line and fueled the growth of the competing tape echo company, Klempt Echolet. In 1969, Dynacord merged with their competitor Echolet, the company famously credited with being in part responsible for the unmistakable live sound of the Beatles. Dynacord continued to produce Echolet devices until as late as 1981. However, by the end of the 60s, Dynacord had begun transistorized club sound systems that included full transistor power amplifier units, mixing consoles, loudspeakers, and performance-like control systems. By the end of the 70s, Dynacord had an extensive high-performance club line on offer. The AD1 advanced digital drums made Dynacord the temporary market leader in digital drums in the 1980s. Their later drum machine, the Percutor, was similarly popular in the European market. In 1990, Dynacord was sold to the American company Telex Communications, and since 2006, Dynacord has been part of the Bosch Group. To this day, amplifiers, mixing consoles, and loudspeakers are still sold under the Dynacord brand. Dynacord is now a market leader in the field of ELA, or electrical loudspeaker systems, public address systems for voice used in airports, shopping malls, stadiums, and the like. They also make PA equipment for music reproduction. At the time of the 2010 World Cup in South Africa, Dynacord provided 9 out of 10 sound systems used at World Cup venues. Their competition in the European market are mainly JBL and their sister Bosch company, Electro-Voice. The Dynacord Echocord Super name was applied to no fewer than 5 models: the Super 61, Super 62, the Super 65, Super 75, and Super 76. The Super 75 and 76 were solid state, while the 61, 62, and 65 were tube-based. Each of the 61, 62, and 65 had the same complement of 7 tubes, consisting of 5 ECC 83s, equivalent to 12 AX7s, a single ECC 82, equivalent to a 12 AU7, and a single EM84 Magic Eye tube that functions as a level indicator. The Echocords were shipped with Telefunken tubes, and if you're shopping for an Echocord, try to find one with the original tubes, as a set of vintage Telefunken tubes can be worth at least a couple of $100s on the used market. From the outside, the S61, 62, and 65 appear similar. Each has 4 inputs, 2 line level or instrument inputs, and 2 microphone preamp inputs coupled to Sennheiser microphone input transformers. Each input has a level adjustment and tone control. The magic happens under the hood, where the AC induction motor drives a tape loop across 6 tape heads, 3 of which are configured as record heads, 2 playback heads, and an erase head. Echo number and frequency are controlled by a switching matrix on the front panel that bring in one or more of the record heads and control the speed of the motor, which is switchable between fast and slow settings. In addition, there's a feedback control labeled reverb duration and a wet-dry mix control labeled reverb strength. The tone of the final mix can be adjusted, and with the pull of a knob, wet and dry signals can be sent to separate outputs, allowing for some degree of image separation. The result has been described as a sublimely smooth echo that's difficult to replicate with digital circuitry. Perhaps it's the tape saturation or the pleasing harmonics added by the tube circuitry, who knows? But the sound of the Echocord and its contemporaneous cousins, the Klempt Echolet and the Binson Echo Rec, are highly sought after to this day. I've purchased this Super 62 from a studio in New York. It wasn't working when it arrived, and our job will be to figure out what's wrong and develop a plan of attack to get this machine back into working order. Once it's up and running, we'll put it through its paces and see if there might be an opportunity to modify the machine and give it some new functionality. This video will be just an introduction, while in subsequent videos we'll cover the repair and testing of the machine. So without further ado, let's get started. We've got something kind of special on the bench today, and this is a Dynacord Echocord Super model 62. Came out in 1964, and this is a tube-based tape echo machine. And I've just acquired this, and we're going to be doing some refurbishing and getting it whipped into shape. It's apparently billed as partially working with some issues with one of the heads in the machine. And we'll set about examining it and refurbishing it as we would any other piece of equipment that was tube-based and of a similar vintage. I haven't opened it up yet, but I'll pop the hood here, and you'll have to excuse the use of this blunt instrument, the screwdriver. But to get the top off this thing, you need to insert some sort of implement in this hole here, and then push the rather sturdy steel lid back against some springs, and then lever it out. So you'll see that there's some bits here that fit underneath this portion, and then there's some very sturdy springs that press against that, holding it in place. And you can see that previous users have left a few scratches here as they've taken the lid off in the past. This is a view of the interior, and you can see the various heads. My recollection is that there are actually 3 record heads, 1, 2, 3, 1 erase head, and 2 play heads. So we have a complement of 6 heads in this machine. It has 6 tubes, and these are mostly ECC 83s, which are essentially 12 AX7s, I believe, and 1 tube that is a ECC 82, and that's essentially a 12 AU7 or I believe it's a 12 AU7 equivalent. The tubes that are in here are actually all Telefunken tubes, which would be the original tubes that came with the machine. So they've probably been operating just fine for the last 56 odd years. And I'll do some testing of them and make sure that they're okay. You can see here the big power transformer. This is the top end of the motor on this pinch roller, and the backside of the machine includes the various ins and outs. There are 2 microphone inputs and 2 instrument inputs, a remote as well. you see a voltage selection switch. This is essentially a universal machine. The mains input is right here, and it has this rather unusual plug that it uses, and that's connected to this end of this connector, which is the typical North American standard. And so we can operate this in North America, even though it was manufactured in Germany. I'd like to get the main chassis out so that I can assess the integrity of the unit. I've already looked at the bottom where we see the type S62 label, and that tells us the model. There was a 61, 62, I think a 65 as well in this in this Echocord Super. See a little bit of rust here on the inside, which suggests to me it might have been stored in a relatively humid environment, but really it's not too terribly bad. And we'll hope for the best and prepare for the worst. So this is a look at the bottom side of the Dynacord with the chassis cover removed. And what we can see here is we have an awful lot of capacitors. Yeah, that's really what this thing is made out of, is capacitors and resistors, and that's about it, and a few tubes. But it's really got an interesting, in my view, construction. We see a mixture of styles. We've got both point-to-point in this area here, for example, with terminal board. And then we have a couple of small circuit boards. We've got one, well, I don't know if that's a circuit board or just an assembly of potentiometers up front for the input and tone control section. Then we have a circuit board housing the various switches that control the selection of the tape heads and so on. But really the business end of this starts over here, where we have the AC input, which goes through a voltage selector and then goes into the transformer through this hole here. And then after being transformed, we have a number of secondary windings which come out, and the main one is rectified here through this selenium rectifier. You can see the designation B300C70 on the side of this selenium rectifier. And what that means is that this is a 300 volt, 70 milliamp selenium rectifier. And presumably that's still good, but selenium rectifiers are famous for failing, and when they do so, they're kind of spectacular. They give off a terrible, terrible smell. And the selenium is toxic. And so it's recommended that these be gotten rid of. And so we'll probably replace this with a bridge rectifier configuration of 4 diodes. And we'll most likely need to include a dropping resistor, because if we use modern silicon diodes instead of the selenium rectifier, we're going to end up with a higher voltage on our main B+. We see quite a few electrolytic capacitors in different sorts of configurations. We have this multi-cap can type. This one here mounts using a threaded base, which is captured with a nut. It has 2 sections. I believe this is the main B+, yeah, it's coming from the selenium rectifier. Main B+ rectification, filtering reservoir capacitor, which I think is 50 microfarads each. There are 2 of these.
We have another large electrolytic capacitor down here. I'm not sure which one that is. It could be our motor run capacitor. There's a capacitor attached to the motor in this piece of equipment. We have another electrolytic, large electrolytic over here. And these blue Siemens capacitors are also electrolytic, as are, I believe, these three here. They're polarized, so those will be electrolytic capacitors as well. All these yellow guys, I believe, are what we might think of today as regular sort of film capacitors. And sadly, we may be in a situation where we need to replace many, if not most, of these. We see some really neat things here. This point-to-point wiring is very much European style. If you've looked at a lot of American radios, for example, you'll not tend to see this degree of structure and organization in the point-to-point wiring. This is more typical of European. We also see the use of a lot of shielded cable. We have, in some cases, low signal levels, and the shielded cable is this brown stuff. It's interesting as well that the shielded cable, interesting to me anyway, that the shielded cables have these little, I guess this would be a shrink wrap end of different colors that kind of designates them, presumably. I haven't figured out what that code is, and I'll have to do that at some point. All of the potentiometers, sadly, are these kind of open wafer types. I don't know if you can see those very well, but they're really old school, which are prone to getting dirty. Here's one right here beneath this cable assembly. Those will be dirty. The good news is they're probably fairly easy to clean. There's a coil here. I think this is part of the oscillator in the erase head. I don't know what this assembly here is. It looks like another coil or inductor of some sort. It's quite a large one. And I do see that, I don't know if you can see this, but there's a little piece of phenolic here that seems to have broken off. Presumably this capacitor was like so, and I guess maybe it was too proud of the base and has broken off. I don't know if that is going to cause us any problems or not, because although there is a terminal tie point here, the two wires that are supposed to be soldered to it are soldered to it, and I think it's maintaining its electrical integrity, if nothing else. But other than that, I don't see any obvious signs of damage or capacitors leaking or capacitors cracking or exploding necessarily. This, of course, is the motor, and we'll be looking at that later in great detail. My understanding is that it's about a 42 volt AC motor. It's an induction motor. And one of the things that would be of tremendous interest is having the ability to control the speed of this motor, but that's not a trivial undertaking. So we'll look into whether or not that might be possible or not. But before we do anything, before we power this up, there's a few things that we'd like to do to ensure that if any of the components in this are faulty, that we don't damage any of the other components. So, for example, if we have blown capacitors or bad tubes, we could overstress the power transformer on power up and find that we blow that transformer, which is probably unobtainable. So we will want to power this up very slowly on a variac. But even before we do that, we want to check the integrity of the transformer and the rectifier and ensure that the primary and secondary windings are not shorted before we apply any voltage whatsoever to it. We'll also, of course, check the fuse and see if the fuse is intact or not. That may give us a hint as to whether or not there might be any trouble. And once we've confirmed that the rectifier appears to be functioning, the transformer appears to be intact, we don't have any blown fuses, what we'll do is we'll remove all the tubes from this and power it up slowly on the variac and make sure that we don't have any excessive current draw that would be suggestive of a short, which again would likely lead to destruction of some of the components. It's really, to me, quite fascinating, the construction here. Might wax on about this a little bit longer, but for example, we have some really very fine wiring. You see this stuff here, really thin wires for what I presume are some of the input sections. Again, a bundle of very thin wires. Some of the wires on this coil are really almost hair thin. And I'm surprised that this coil is not encapsulated in some sort of tin enclosure to protect it, but it isn't. I guess it's enclosed in this chassis, and that is deemed to be good enough. So I'll do a little bit of analysis of some of the things that I mentioned and be right back before we power it up with the variac.
Well, that's all the time we have for today's video. Future episodes in this series will cover the disassembly and servicing of the Dynacord, sourcing of replacement parts, reassembly, and the potential for modifying the machine's tape speed. I hope you've enjoyed this introductory video. Thanks for watching.